సింగిల్ కరెక్ట్ ఆన్సర్ టైప్.
ఓకే వచ్చేస్తుంది ఆటోమేటిక్ అక్కడ అదే ఉంది కదా, అదే ఉంది కదా.
ఫస్ట్ నుంచి చెప్పేటప్పుడు అయితే Hello everyone, today we are going to start 9th class toppers program. So 9th class toppers JEE NEET foundation. In 9th class toppers we are going to start with the chapter 5. Our chapter 5 is behavior of gases. So let us start with behavior of gases, single correct answer type questions. Okay, so let us start with the first question. The first question is, the graphs plotted for Boyle's law are known as. See, the graphs plotted for Boyle's law are known as isotherms. So the isotherms are, why we are calling them as isotherms? See here, actually according to the Boyle's law, the relation is at constant temperature. Constant temperature, pressure is inversely proportional to volume, means at constant temperature pressure increases, then volume will be decreases. If you take a graph between pressure and volume, then the graph will be like this. The graph will comes here, it is the pressure and here it is volume. The graph will be like this. So if pressure is decreasing, then volume will be increases. So we can say it is as hyperbola. Pressure volume, the graph will be hyperbola. This graph is known as isotherm. Why we are calling as isotherm? Because this graph drawn at constant temperature. The graphs drawn plotted for Boyle's law at constant temperature are said to be isotherms to each other. Those are called isotherms. Okay, so if the pressure constant, suppose if you keep the pressure constant and if you plot a graph between volume and temperature, then those graphs are said to be isobars. Okay, isotherms, isobars. Isotherm at constant temperature, isobars are at constant pressure. You have taken volume and temperature. Okay, so here isobars is for the at constant pressure, and isostars and isomers are completely different. So I will go with the first option. Okay, now comes to the second question. Next question, combined gas law is expressed mathematically as. What is, first of all, what is meant by combined gas law? Combined gas law is nothing but we can take as a ideal gas equation, because ideal gas equation we are combining Boyle's law, Charles' law and Avogadro's law. In Boyle's law, what is Boyle's law? Actually, pressure is inversely proportional to its volume. So if you take Boyle's law, pressure is inversely proportional to its volume. If you take Charles' law, volume is directly proportional to its temperature, and Avogadro's law, volume is directly proportional to its number of moles. If you combine these three laws, the mathematical expression will be PV equals to nRT, because if you take P proportional to V, so in place of V we can write T. V is directly proportional to N. Based on this we can conclude the combined gas laws as PV equal to nRT, and this is also known as the ideal gas equation. Here if you take N equals to 1 mole, and R is called universal gas constant, and at different units it has a different value. So if we consider this is the constant and this is 1 number of moles, then this is PV equal to T. Then PV by T equals to constant. Then if you take for two different types, then P1 V1 by T1 equal to P2 V2 by T2. P1 V1 by T1 equal to P2 V2 by T2. This is called the mathematical expression for combined gas laws. Okay, let us see in which option it is there. Comes to the first option, P1 by T1 equal to P2 by T2. No, this is not one, because here volume is missing. He said combined gas loss. Come to here, volume and number of moles only there. There is no about pressure and nothing about the temperature. Comes to here, P1 V1 by T1 equal to P2 V2 by T2. This is the expression we got here. So the answer is C. See why this is called Ampton's law actually. P1 by T1 equal to P2 by T2 at constant volume we will consider. Comes to here, this is called Avogadro's law. This is not the combined gas loss. This is expression for Avogadro's law. Comes to here, the D option, R1 by R2 equal to root M2 by M1 is rate of diffusion of gas loss. See, that is the expression for rate of diffusion. So that is also not cut. So our correct answer is C. P1 V1 by T1 equal to P2 V2 by T2. This mathematical expression we got from these three laws. Okay. So our option is C. Comes to the next one. See here, under similar conditions of temperature and pressure, the rate of diffusion of a gas is. Under similar conditions of temperature and pressure means we can consider those as the at constant temperature and pressure, the rate of diffusion of gas. This is called rate of diffusion of gas. See, R means rate of diffusion of gas is inversely proportional to square root of its density. Once it is a density, obviously we can consider that as a molecular mass or molecular weight. So the rate of diffusion of a gas is inversely proportional to square root of its molecular weight. Sorry. So let us see here. Under similar conditions of temperature and pressure, the rate of diffusion of gas is, first one, directly proportional to its molecular weight. No, the statement is inversely proportional to, but here given directly proportional to. So this is the wrong option. Next, inversely proportional to its molecular weight, but it is inversely proportional to but square root of its molecular weight. But here they given direct molecular weight. So the second option is also wrong. Comes to the third one, again here the statement is directly proportional to square root of its molecular weight. That is not directly proportional to, that is inversely proportional to square root of its molecular weight. So the third option is also wrong. Comes to the fourth one, inversely proportional to. Under similar conditions of temperature and pressure, the rate of diffusion of a gas is inversely proportional to square root of its molecular weight. That is the statement for rate of diffusion of gases. Okay. So our answer is D. Inversely proportional to square root of its molecular weight. Okay. Now come to the next question. The pressure of a gas will be dash when the volume is decreased. Here clearly they given in the bracket at constant temperature. So at constant temperature, pressure is inversely proportional to its volume. This is called Boyle's law. The name of this law is called Boyle's law. At constant temperature, pressure of a gas is inversely proportional to its volume. Inversely proportional is nothing but if pressure increases, if pressure of the gas increases, obviously volume of the gas decreases. Then if volume of the gas is increases, then pressure of the gas will be decreases. Both are inversely proportional to each other. So the pressure of a gas will be dash when the volume is decreased. Volume is decreasing, then pressure should increase according to Boyle's law at constant temperature. So I will go with the option A. The given options are increased, B is decreased, C becomes 0, D is remained same. No, both are inversely proportional. Volume once decreased, pressure obviously increases. So I will go with the first option. Okay. Now comes to the next one. Here they given the numericals. Let us see the first one. The pressure of a gas is 2 atmosphere at 5 liters. If its pressure is increased by 3 units, then what will be its new volume? See here, from the given question, first we have to take the data. What is the data given? See, if the pressure of a gas is 2 atmospheres, 2 atmospheres means pressure is given. Pressure means P1 equal to how much? 2 atmospheres. At 5 liters, 5 liters means volume also given, V1 equal to 5 liters. If its pressure is increased by 3 units, 3 times, if they say, we have to multiply with 3. They said 3 units, so we have to add 3. Then the P2 will be, already P1 is 2, it is increased to 3 units. So 2 plus 3 equals to 5 atmospheres. So P2 will be 5 atmospheres. Then what will be its new volume? So he is asking to calculate V2. Let us see, given pressure is given, P1, P2 is given, V1 and is given, V2 is asking to find. What is the relation between pressure and volume? It is Boyle's law. What is the relation between pressure and volume? Pressure is inversely proportional to volume, means PV equals to constant. So if you take it two different gases, this one we can write as P1 V1 equals to P2 V2. P1 V1 equal to P2 V2. So according to this formula, already we know P1 value, V1 value and P2 value, we have to find V2. So take V2 equal to P1 V1 by P2. So what is P1 here? 2 atmospheres. What is V1? 5 liters by P2 is 5 atmospheres. So 5, which is equal to 5 get cancelled. So 2 is left. So the new volume is 2 liters. If the pressure of a gas is 2 atmospheres and volume is 5 liters, if its pressure is increased to 3 units, means 2 plus 3 equal to 5 atmospheres is P2, then calculate V2. So this is the process to calculate the V2. Okay. So V2 value is 2 liters. Check the options once. First option 2 liters, second option 3 liters, third option 4 liters and fourth option is 5 liters. Let's check. The first answer is 2 liters and this is the numericals we can do based on the Boyle's law. We have to remember that formula. What is the Boyle's law? P proportional to 1 by V, then PV equal to constant, then P1 V1 equal to P2 V2. So whatever he is asking we can find based on that one. Okay, thank you. Comes to the next question. Which of the following is correct symbolic representation of Boyle's law? Just now we discussed about the Boyle's law. Boyle's law is nothing but P1 V1 equal to P2 V2. I am writing directly the formula because in the previous question just now I explained the Boyle's law. PV equal to constant, then P1 V1 equal to P2 V2. This is the mathematical expression, correct expression for the Boyle's law. Let us see in the options. First option is given P1 P2 equal to V1 V2. No. Second option is P1 V1 equal to P2 V2. This is the correct symbolic representation for Boyle's law. See the third one, P1 by V1 equal to P2 by V2 is given. No, not the C. Then not P1 plus V1 equal to P2 plus V2 is given. So D option is also wrong. The correct option is B option. Okay. Comes to the next one. Yes, see here one more numerical. Let us see what is the problem given here. 300 ml of O2 is collected at a pressure of 380 mm of mercury. So 300 ml is given. Milliliters is generally the unit for volume. So indirectly volume is given. How much is given? 300 ml. 300 ml of O2 is collected at a pressure of 380 mm of Hg. 380, this is mm of Hg is also units of pressure, right? So pressure is given 380 mm of Hg. Mercury we can write like this. What volume will this gas have at 1 atmosphere pressure? So the first one you consider as P1 and V1. He given the another pressure, that atmosphere. What is P2? Is 1 atmosphere, they said. So he is asking to calculate V2. See, while doing the numericals, we have to maintain throughout the problem, throughout the solution, the same units. If you are maintaining the CGS units, all the values should be in CGS. If SI system, all the values should be in SI. Excuse me. If you see, pressure is 380 mm of Hg is given. Here pressure is given in atmosphere. So we have to convert this mm of Hg into 1 atmospheres. So how to convert mm of Hg into atmosphere? See, generally 760 mm of Hg equals to 1 atmosphere. 76 centimeter of Hg is also 1 atmosphere. These are the conversions actually. Here we want to convert this mm of Hg into atmosphere. So obviously 1 mm of Hg will be 1 by 760 atmosphere. So by converting this mm of Hg, you have to divide with 760, right? Why I took 760? Because that given in millimeters. If they given in centimeters, you have to divide with 76 to convert that centimeter of Hg into atmosphere. So once if you convert this 380 by 760 atmospheres. So now you can check, volume is in ml, pressure is in atmosphere, P2 is also in atmosphere. So now we can do the problem. Actually this is also Boyle's law related problem only. Already we know the formula, P1 V1 equals to P2 V2. Already we know from the given data what is P1. P1 is 380 by 760 into V1 is 300, which equal to P2 is 1 atmosphere into V2. So we want V2. So V2 equal to, if you observe 380 by 2 times if you take, that will be 760. So if you cancel 380 by 760, you will get 1 by 2. Again with this 2 you cancel this one 150 times. So V2 equal to 150 ml. So we have found the new volume, that is 150 ml. One more time, see the problem. 300 ml of O2 is collected at a pressure of 380 mm of mercury. What volume this gas have at 1 atmosphere pressure? So volume we have taken, pressure P1, P2, V2 also taken, and here mm of Hg we have converted into atmospheres, and then we applied the data into the formula, that is P1 V1 equal to P2 V2. Okay, then we got the volume is 150 ml. Let's check where is that 150 ml, in which option we have the answer. First option is 600 ml, second option is 150 ml is given, third option is 900 ml not, and D option is 75 ml. So our answer is 150 ml. We will go with the B option. Okay. Okay. Comes to the next question. See here, the next question, what pressure is required to compress 196 liters of air at 1 atmosphere into a cylinder whose volume is 26 liters. So here the information is given about pressures and again they are measuring the volume. So again this is also based on Boyle's law only. What is our Boyle's law formula? P1 V1 equal to P2 V2. First of all, note down the data. What is the data given? What pressure is required? Now he is asking to calculate the pressure is required, means P2 is asking to compress 196 liters of air. 196 liters means V1 is given. Actually atmosphere a cylinder whose volume is 26. So he is asking to calculate P1, then V1 equal to 196 liters and P2 is given as 1 atmosphere and V2 equal to 26 liters. So substitute these values in the formula, then we will get P1 into 196 equal to P2 is 1 atmosphere into 26 liters. Then if you calculate P1 equal to 26 by 196. If you do this calculation, we will get the answer. See 26 196, how to calculate this one?